Shapes again that some of y'all have never seen before, let alone actually used before when you're doing any kind of formulas. So today we're going to be identifying these. We did go over these when we did the section on all the quadrilaterals, a lot of these already about what they look like and their properties. But now we actually have to do formulas with them that deal with area. The trapezoid is going to be the longest formula that we deal with. This is what a trapezoid looks like. It has a base on top and bottom. These are the two sides that are parallel to each other. Guys, you need to recognize that the bases are the ones parallel because they can be turned. They don't have to be the top and bottom. They can be turned on their side. It's the two that run parallel. The two that don't are just outside edges. Okay? And the height is always going to be at a right angle between those two bases. The formula for this is going to be 1/2, starts off with the 1/2, times the height, times base 1 plus base 2. Basically what you're doing is averaging the top and bottom and multiplying it by the height. And that's the concept behind this. So when we look at this, we've got to go through and identify all the pieces that are going to go in here. We start off with area equals 1/2. In this picture, which number is the height? 4. It doesn't have a dashed line, but it does have the right angle. That outside edge is the height, even though it's got a solid line because it's at a right angle. Good. So 1/2 times 4 times base 1 plus base 2. What are the two bases? Good. 6 and 7. Now, listen, guys, I would not type this like this on a calculator. Y'all know I tell you exactly how to type things. My opinion, because parentheses are a pain on this calculator, the very first thing I would do is cross this out and do 6 plus 7 on your calculator and get an answer for that, which in this case would be 13. Then I would type it on a calculator to get the whole thing. 1/2 times 4 times 13. Multiply that, tell me what you get. 26. And that would be what units, guys? It's area, so it would be meters squared. Good. Good. Okay, let's do it again. Area equals 1/2 times the height. Which number is the height in this case?
8.4.
Good. No issues identifying that. The 8.4, and the two bases are going to be the 11.8 and the 6.3. Again, I personally would recommend that you go ahead and take care of the addition inside the parentheses first so that you don't mess up order of operations. It's very easy to mess that up. What is 11.8 plus 6.3? 1. 18.1. Then I would use your calculator to go through and type the rest of it all together. The 1/2 times the 8.4 times the 18.1. 76.02. Ooh, good one. Thank you for that's going to be one you got to make sure you round correctly. Guys, a 76 with a 0 after it that's got a 2 behind it. Would it round up or stay the same? So it'd just be 76 meters squared. You can write 76.0. I'm not going to take off, but there's no need to write it. You don't need it. It's the same thing. So you can write it either way, but be aware it's the same thing as just 76. Okay. Anything about that formula that you have a concern or question about? Listen to me, guys. This list of formulas, you got to know them. Please do something to highlight. This is a formula you've got to know for your test. So make a flashcard of it. Make a list of these. Do something. Don't get caught with a list of them, because every year I give like 3 zeros on this test for people trying to have the formulas with them. Don't be stupid on this test. Okay, you actually have to learn the formulas to be able to do this. And these don't go away. We keep using these formulas throughout the rest of this year. So please, these are something you got to know. Okay, guys, here we go. The next one. These are going to be rhombi and kites. Guys, a rhombus is basically just a parallelogram, but all 4 sides are the same. Okay? It's like a diamond. This is going to be a rhombus. This is going to be a kite. Kites have the 2 sides that are the same at the top and the 2 sides the same at the bottom. What's unique about them is they actually share one area formula. That formula has to do with their diagonals. Guys, we've never had a formula that dealt with diagonals before. So you're going to be dealing with the length of the diagonal that goes this way. I write it on the outside so I can clearly see what it is. I have a diagonal goes right through the center here. That's going to be diagonal 1 going this way. Same thing on a kite. Okay. And the area formula is based off those two. It is going to be 1/2 diagonal 1 times diagonal 2. It is an extremely easy formula. It's like 1/2 base times height, but it's using the two diagonals. That's the only difference. Again, it's just a matter of knowing this formula and remembering that this is what applies to these shapes. The formula itself is not hard. This is one of the easier formulas you're going to use. Now, when you look at these shapes, you have to be very careful because you've got to know exactly what they're giving you. If they give you a measurement that is right here on this piece, they are giving you the measurement just for this piece of it. Unless they tell you it's the whole thing, it's just the one that it's sitting on. So if this is 6 on this side, then it's going to be 6 meters on this side, which means this whole diagonal going this way is actually going to be 12. Good. And if this piece right here is 4, then this piece right here is 4 also, because the diagonals are bisected in these. And rhombus diagonals are bisected. So that means this diagonal going this way is actually going to be 8. I always write my diagonals on the outside so that I don't mess up and just use the wrong numbers. Then it's just easy plug into the formula. Area equals 1/2 times diagonal 1 times diagonal 2. It makes no difference which one comes first. None whatsoever. Okay, do the math. What's that give you? 48. And that would be meters squared. 48 meters squared. Yeah, because half of 12 is 6. That makes sense. Okay, on the next one. Guys, look. In a diamond, these two diagonals are cut in half. They give you both of them. You just need to add it together to get the diagonal length going this way. 3.1 plus 3.1 is going to put it at 6.2. The diagonals going this way are different lengths. They are not congruent to each other. The ones that go the long way in a kite are not the same. You have to be careful because people assume they are and they're not. It's not like a rhombus. So you have to add those together. What's 4.3 plus 6.5? 10.8. There you go. And then just plug it into your formula. Area equals 1/2 times diagonal 1 times diagonal 2. Again, it doesn't make any difference which one you put as diagonal 1 and which one you put as diagonal 2. None at all. Hey, what's that give you?
33.48.
Okay, wait a minute, I got different answers. Try it and make sure. Did y'all get the 33?
Yeah.
Okay.
Oh.
Multiply and then divide by 2.
No, I looked at the 0.8.
As times 8. Yeah, you got to be careful. I'll make my little decimals a little clearer. That's my fault. Okay, we all good? Okay, guys. So then the next thing they're going to do is actually have you do them with some special right triangle stuff and some word problems. So let's go ahead and get to those. I think the word problems are first. Okay, yeah, the area, it's a backwards problem, guys. The area of a kite is 92 inches squared. If one of the diagonals is 22, find the other diagonal. This is just formula. You got to write the formula. Area equals 1/2 diagonal 1 times diagonal 2. When you work backwards, you always start with the formula and you plug in everything you know. What do we know the area is? 92 equals 1/2 times, what's one of the diagonals? 22. And what's the other diagonal? It could be anything you want. I'm going to keep it as diagonal 2, but you can keep it any variable you want. It doesn't matter. I tend to keep it whatever it's called in the formula, but it doesn't matter. Alright, guys. First thing I would do is take half of 22. It's going to make your life easier. Go ahead and deal with this multiplication. What is half of 22? 11. Just multiply half of 22. And then what do we do to undo multiplication? Divide. divide by 11, divide by 11. Our final answers are going to be rounded to the nearest 1 decimal place, the nearest tenth. So divide that out and see what you get.
8.4.
8.4. Okay, now if I write an answer for this, it's going to be 8.4 what?
Inches.
Inches. Plain inches, because we work backwards. This is a distance. This is not the area. Good, 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 good. Nice. Now, I will tell you that the next one is backwards on a trapezoid, and the backwards on a trapezoid requires a little more work, especially depending on which piece they're looking for. Please just start with the formula. Everything is about starting with the formula. So here we go. So the area of a trapezoid, so we're going to write the trapezoid formula, which is area equals 1/2 times the height times base 1 plus base 2. Okay, so let's go through and fill in everything. What's the area?
127.
Okay. Equals 1/2 is just 1/2. What's the height?
13.
13. And then what's one of the bases?
11.
11 plus B2. Okay. A lot of people mess up what to do on this, so guys, pay attention, be careful. First thing I would do, just like you did on the other one, I would take and do, I'll highlight instead. I would do this part of it just like we did on the other one. Deal with that 1/2 and that number first. What is 1/2 times 13? 6.5. And then 11 plus B2. Okay, that 6.5 out in front is multiplied times the stuff in the parentheses. In order to undo multiplication, we are going to do what? Divide. We're going to go ahead and divide. So we're going to go ahead and divide both sides by 6.5. What's 177 divided by 6.5? 27.23. Is that, does it end like that? Okay, so within the problem, that's great. Within the problem, we need 2 decimal places, so that's perfect. Nicely done. 27.23 equals, the 6.5's cancel out, and we get 11 plus B2. Now, how are we going to get rid of that positive 11 from that side?
Subtract it.
Subtract it, because it's added, so the opposite of that is going to be to subtract it. And when we do 27.23 minus 11, that's going to give us 16.23 equals B2. Now, my final answer has to be rounded to 1 decimal place. 1.
So 16.2.
So a 0.2 with a 3 after it would stay at 16.2. And it would be, thank you, centimeters, plain old centimeters. So you distance, that's it, centimeters. Nice. Okay guys, the last thing we got to deal with is area involving special right triangles. Guys, for those of y'all that didn't learn special right triangles the first time, now's your chance. You got to ask questions and you got to figure it out, because I'm going to tell you right now, they're going to show up for the entire rest of the semester. They're on like about 2/3 of the test we take, 3/4 of the test we take for the rest of the year. Gotta know them. Here we go. Okay. Area of this rhombus. Area of this rhombus. Okay. So the formula is going to be area equals 1/2 diagonal 1 times diagonal 2. We already did that. I'm not worried about you learning the formula right now. I'm worried about you applying it and finding the diagonals. So the very first thing, if this piece right here is 3 on a rhombus, then this piece on this side is also going to be 3. So this diagonal right here is going to be 6. That one, not hard. The other diagonal is the one that you have to use special right triangles for. First of all, in a rhombus, the diagonals are going to intersect at right angles. So this is going to form a right triangle that is a 30, 60, 90 triangle. Currently, we have what leg? What is this 3 right here? Long leg, short leg, or hypotenuse? It is the short leg. And we need to go from the short leg to the long leg, because we need to get that diagonal. To go from the long leg to the short leg, what do we need to multiply by? Radical 3. So grab your calculators. Do 3 times 3 square root equals. Now I think this is a weird roundy one. Trying to remember. It's like 5. Is it 5 point like?
5.19.
Okay, so here we go. Within the problem, we read it rounded to 2 decimal places. The only problem is when we try to round this one to 2 decimal places, a 9 with a 6 after it is going to have to round up. So what's it actually going to round to? 5.20 or 5.2. I would write 5.2, but 5.20 because it goes from 5.19. The one number up from 19 is 20. So it's going to be 5.2 here. And guys, if it's 5.2 on this side, then it's got to be 5.2 on this side. And if they're both 5.2, then how long is this diagonal across here? 10.4. Once you, bless you. Once you have the diagonals, you plug it in. The area is actually the easy part. Area equals 1/2 times diagonal 1, which is 6, times diagonal 2, which is going to be 10.4. Okay. Grab your calculators. This is one of those you can type just straight across. You don't need to do any, like, there's no parentheses, no addition. Just type it straight across. What's it give you?
31.2.
What was it?
31.
Oh, 31. I thought you said 101 point. I was like, that's way too big. 31.2, and that'd be meters squared. Thank you. That was my fault. I misheard you. Perfect. Okay, last one, guys. This is a square. It's a rhombus. It's guys, a rhombus is a square. So, this particular rhombus is a square. A square is always a rhombus. So when you look at this one, guys, it's creating 45, 45, 90 triangles. In a 45, 45, these are easy if you know the rules. Guys, in a 45, 45, 90, what's true about the legs? They're equal. So if this one's 5, this one is 5. That's it. And if this one is 5, then this one's also got to be 5. And if this one is 5, this one's also got to be 5. It's a square, guys. A square's got equal sides on all of it. All the diagonals are cut equally. It's 4 of the same exact triangle. So because of that, the diagonals are fairly easy. The diagonal going this way would be what? And so would the diagonal going this way, because the diagonals in a square have to be the same. Which means your formula is just going to be area equals 1/2 times 10 times 10, which, guys, you shouldn't need a calculator for, because 10 times 10 is 100, and what's half of 100? 50. Use a calculator if you need one. I'm just saying, sometimes it's easier just to think through the problem. Okay, so that's your notes for today. Go ahead and take this and put this in your folders, and we're actually going to go backwards. Like I said, we went out of order today, and we're going to go